Epona, my horse, holds a dear place in my heart, much more than Ln.
Are you sure about that?
Sure, you can cross Hyrule Field on foot, but it's pretty tedious and takes forever. Having Epona makes this mundane task much more fun, and allows you to cross the field much more quickly. In the same way, we can take derivatives using the quotient rule, but it's pretty tedious and takes forever. Having ln of x makes this mundane task much more fun, and allows us to compute derivatives of quotients much more quickly. For example, to compute the derivative of f of x equals sin x cosine x over x squared plus 1, we simply take ln of both sides, break down the right hand side with ln rules, and then take the derivative of both sides. This yields f prime of x over f of x equals cosine of x over sin x minus sin x over cosine x minus 2x over x squared plus 1, or rather, cotangent of x minus tangent of x minus 2x over x squared plus 1. To finish the problem, we simply solve for f prime of x algebraically to obtain f prime of x equals sin x cosine x over x squared plus 1, all times cotangent of x minus tangent of x minus 2x over x squared plus 1. See? That was pretty quick. If you'd like, try using the quotient rule to solve this problem and see if you can work it out faster than this. Comment down below if you get the same answer. Epona is so much more than a means of transportation. Although this sounds obvious, I'd like to point out that we can't perform horseback archery without Epona. Thus, we can't collect the big pose to obtain our last bottle, and we can't obtain the largest quiver from Gerudo Valley without Epona. In the same way, we need ln of x to take derivatives of a function f of x raised to another function g of x. For example, to compute the derivative of h of x equals x squared plus 1 to the sine of x, we simply take ln of both sides, break down the right hand side with ln rules, and then take the derivative of both sides. This yields h prime of x over h of x equals cosine x times ln of x squared plus 1 plus sine of x 2x over x squared plus 1. To finish the problem, we simply solve for h prime of x algebraically to obtain h prime of x equals x squared plus 1 to the sine x, all times cosine of x ln x squared plus 1 plus sine of x 2x over x squared plus 1. See? Not so bad. If you know another way to compute h prime of x, let me know in the comments down below. I'd love to check it out. Anyway, we have seen that ln of x makes quotient rule derivatives much quicker to compute, and also allows us to take an otherwise impossible derivative of a function raised to another function. But aren't there other logarithms? Yes. Just like there are other horses besides Epona, there are other logarithms besides the natural log. If you and your friend were to pick a background horse to ride at Lon Lon Ranch, chances are you'd pick a different horse. This difference comes from the fact that your individual preferences bias your choice of the horse that appeals most to you. There is only one universally chosen horse which requires no individual preferences to be desired, namely Epona. This universal property is what we call natural, And so too does ln of x get the adjective of natural. Maybe my favorite log base is 2, since I love the binary Boolean nature of 2 in computer science. And perhaps you like log base 10, because, well, it's pretty awesome. There is only one universally chosen logarithm, which requires no individual preferences to be desired, namely ln of x. And so concludes our horse tale. Math, just like anything else in life, gets easier the more you see it. Take, for example, your favorite movie. I bet you could watch it for the log base 2 of 64th time and still find some new Easter egg in it. So now that you've seen this video n times, see if you can fill in any gaps by watching it n+1 times. And if you have any questions, be sure to leave a comment down below. If you found this video helpful or interesting, be sure to give it a like, as it helps support this channel. New videos are posted every Tuesday at 2. To never miss out, be sure to subscribe and hit the notification bell. Thank you so much for checking out this week's video. See you Tuesday!